So how do we model this? In this position here, we have the block and its equilibrium position. We can see here that the block has been displaced over to here. And what we're going to do is call this X max. If we pull the block over to that location, that's the farthest it will go. And I'm going to draw this as a graph where this is the displacement and this is the time. So I'm drawing the block kind of backward. But what you can see then is at time 0, it's at an X max position. And when it completes the cycle, it will be all the way back there. Now in the process, this block, once it's released, it will go through the equilibrium point, go to this extreme point, and come back to its original position. So we call this position x0. The position at time 0, it's the X max. And at about half the time, it will be at a position of minus XO. Draw that again. So that's the position it's going to take, back and forth as it moves back and forth. Now, so we can label this as XO. We label this as 0. We label this as minus XO. And we're back to 0 and back to XO again. And that's what this graph depicts. Well, we don't normally look at the graph in that orientation, but I just wanted to point that out, that the x-axis here is actually aligned, and drawing the graph this way, it's aligned like this. But to get it the way we normally look at graphs, we need to rotate this graph counterclockwise 90 degrees so that this is x. And we have our x max, which is x0, and we have a distance down there that's minus x0, and here's our equilibrium point 0. Here is the time, and this represents the whole period. And we said after the period is complete, it will return to x0, and at halfway, it will be at minus x0. So that is our graph. We've just redrawn it halfway. Now, we could put time there like so, the period. We can also put the radians. So this is 2 pi radians. This is 0 radians. Halfway through is pi radians, pi over 2 radians, and 3 pi over 2 radians. And so this represents half the period, 3/4 of the period, 1/4 of the period. So we have our graph of modeling the position of this body versus time. Now, you probably recognize that this is a cosine function. So what we could say then is that the position x is given as a cosine function, and the amplitude is x0, the max. So we now have a description of exactly what the position is over time. And we know omega is 2 pi over t. So that is our model of the position versus time. Now we have a graph, so we could do RGA. I'll do it here in the center. What we can read is x and time. The slope is delta x over delta t. Oh, which is the velocity. The velocity. And the area is x times t, which is meters seconds, which is nothing of value. So the slope, but we can see the slope is changing. Well, if the slope is changing, the velocity is changing. Now, for those of you in calculus, you could see then that we would, if we wanted the slope, we would do dx dt. And the derivative of cosine is negative sine. So we have negative x0 omega sine omega t. And so that is the equation for our velocity. Negative xo omega sine omega t. In our next installment, we are going to look at velocity and modeling the velocity.